This is a new part we just added. It's going to be kind of get technical and then back out and get technical. All of this is just to kind of familiarize yourself with some of the terms, what you have out there and everything. So we're going to look at the different protocols we're going to see in our buildings. We're talking about, you know, the BACnet, LON, into COM4. So what the protocol is, well, do a little history first. So like Rob said, when they first started with DDC and started going to electronic control, you know, all these manufacturers came up with their own proprietary protocols into C-Bus, COM4. And building owners, you know, being tired of being locked into that, you know, needed something open. So they started, you know, looking for an outside source to develop protocols that these controllers can talk to. So the open protocols, the two main open protocols you'll run into are LON or BACnet. So we'll look at a little bit about LONWORKS, and we'll get into some BACnet stuff, go through some of the terms and how the different ways you can talk BACnet. And then we'll get into Modbus, talk a little bit about a newer protocol that's coming along, SNMP, which is an IT protocol. And then we'll go over and do a little review on the existing proprietary protocols out there and what you can and can't bring into a Niagara system. So a protocol, I kind of like my analogy for this. So you have different types of buses, whether it be, you know, an RS-45 or IP or RS-232. And I like to say that that's the kind of road that it is. You know, RS-45 is a two-lane highway, and Ethernet IP is the interstate. What the protocol is the language that the street signs are on. So if you only speak German, you can't drive down a road that only has French street signs because you don't know which way to go. So the protocols, we're talking about the language that's going across the wire. And different protocols are only for different types of roads, and a lot of protocols can go over several different types of roads. So we'll start with LON. So when we first started looking at open protocol systems, Echelon introduced LONWORKS, and they started developing it around 1989. And what Echelon did is they took a different approach to it than some of the other people. They actually developed and manufactured their own chips, their own Echelon LONWORKS chips. And because they had their chip and all their protocols and all their stuff was inside this chip, it was real easy for manufacturers to say, well, I just need to buy one of these chips, put it in my controller, tie my points to this chip, and then everything talks. So that's why LON was so big to begin with, is because it was really easy for Honeywell, Johnson Controls, Trane, right out of the gate to say, yeah, we have an open system. Because all these building owners are saying, we want open protocol systems. They had to, you know, figure something out. So LON is a hardware-based integration. If you have a LON controller, it has a chip in there that was manufactured by Echelon. So, you know, the good and bad of that is Echelon kind of drives some of the pricing on that chip. But the good of that is, you know, if the one company's making all the chips are going to be able to talk to each other. So you have very little problems with communications between LON devices because it's all got the same chip inside of it. Yeah, COM5 in Trane speak is LON. And one thing you'll hear in LON is the term flat LON. And flat LON is not the Niagara-based LON, it's the LON that Echelon kind of developed. And it's a truly open LON system where everything in the whole system is LONWORKS, which is great for a building where you're coming right out of the ground and you can say, I want everything LON, and I don't care if it's Trane LON, Honeywell lawn or Johnson lawn, it's all lawn. It all meets these very strict requirements, and it all talks. So the pros of that is you can work on any part of the system from anywhere in the system because everything's flat. Everything's on the same plane. And every controller can directly communicate with each controller on that system. The problem with that is it's LAN only. So if you already have a building that has some BACnet in it, you can't bring it into a true LAN, flat LAN system. And then some cons to it is the way flat LAN works is you have to have this separate server that handles all the communication between all the LAN devices, and you have to buy credits for that server, and changing anything out on that kind of system can be very time consuming because you have to resync everything up because it's all on a flat peer-to-peer network. So on a flat LAN system, there is no front end or server or anything. Everything just talks to each other, and there may be a LAN device that can give you graphics, but it has no higher ranking than the VAV controller on the wall. All right, so there's two common, the term physical layers used in LONWORKS, and physical layers is the type of road. So LAN uses their own free topology 2-wire bus, and that's the most common. That's what all your controllers would be, is that 2-wire bus that's running through your building. That's the LONWORKS bus. And then also in LAN, you can take that information from the 2-wire bus and convert it over to an Ethernet bus to be able to expand on your system. Because, you know, on any kind of 2-wire or 3-wire bus, you've got limitations there on how many devices you can have on it, the length limit and all that. So what they do is we convert that information over to IP so that we can distribute it, whether it's be across the building's network or the internet. All right, so the 2-wire bus, which is probably, if you have LAN, is what's running throughout your building. It's 2 wires. It talks at 1 baud rate, so it's got 1 speed, 78,000 baud. And you can run it up to distances between 4,600 to almost 9,000 feet, depending on the type of cable used and all that. LAN is very robust and can handle a lot of varying field conditions. The advantage to LAN, in my opinion, is I can run LAN even if I don't have approved LAN wire. A lot of times you can get away with a lot more with LAN. It's not as finicky as a BACnet bus or a COM4 bus, where you have one short and you have to, you know, the whole bus goes down. The other nice thing about LAN, and I have this on here, is it's polarity insensitive. So there's no plus or minus. You just hook the wires up, and as long as you don't have 2 wires crossed, it's going to work. And the addressing with LAN, each chip comes burned from the factory with a unique address in it. So there's no setting dip switches out there. There's no having to figure out having 2 things addressed the same. So the advantage of that is, less mistakes on addressing and setting something in the wrong dip switch, and you have 2 things fighting on the system. One disadvantage to that is if I have a controller that goes bad and I need to change it out, I can't just put a new controller in there and set it to the same address. I've got to go to whatever is managing the system and say, this controller is now this address instead of this address.
But you did say it's polarity based.
It's polarity insensitive. Yeah. So a little note on LAN addressing. So like I said, each chip comes burned with a unique address. And both in LAN and BACnet, there's 2 types of addresses. You actually have the physical address for the wire, and then you have the software address. So you have a physical address and a software address. In LAN, the physical address is the Neuron ID, and that's what you have on all those chips that's burned in. The software address is what the whole system sees, and that's the channel, subnet, and a node. And when you commission a controller, you're saying, I want you to be on this channel, this subnet, and you're this node. So this address is used when you jump between buses. This is a system-wide address. The Neuron chip really is, that address is just for the stuff on that bus, from the router or front end all the way down to the end device. So like I said, you can do LONWORKS over IP. So basically, you're just tunneling. You're saying, I want this data to tunnel over the internet to this other bus I have somewhere else. And it's used to convert that 2-wire bus to something that you can get on a network. Now, one disadvantage to LONWORKS IP is it requires some hardware or some kind of piece of software somewhere on the system that's handling the communication between all the different IP routers, the things converting the buses. And one thing, but the difference between LON IP or LONWORKS and BACnet, and back up a little bit. You know, there's always people saying, well, I like LON better, or I like BACnet better. To me, they both have advantages and disadvantages. The two main ones is LON is a lot more forgiving on the install. It's a lot more robust network. BACnet is a lot easier on the programming side or communication side. It's not as complicated as LON. LON can get pretty complicated when you're trying to get stuff to talk between each other. So on the software side, BACnet has an advantage. On the install side, I would say LON has an advantage. It's more of an advantage of ease of use rather than, they both work. It's just one's easier to use than the other. All right, so some terms you're here in a LON system. You'll have SNVT, SNVT, and they just say that it's a SNVT. And that stands for Standard Network Variable Type. So this goes back to LON being a little more complicated on the hardware side. BACnet says I'm an analog point. I'm a number. LON says I need to know what kind of number are you. Are you a temperature number that's up to 4/1000ths of a degree in Fahrenheit? Then you're this certain kind of variable. And it doesn't say on here, yeah, okay. So there's 170 different types of standard variables for LON. NV, a network variable, that's what LON calls the points talking across the bus. So when you have somebody say, you know, I need this, does this controller have this NV, this variable? You know, is it pulling this point out where I can see it from my front end? And a little thing, LON actually stands for Local Operating Network. And both LON and LONWORKS are just trademark names from Echelon, the people who developed it.
You said this is when we post.
Yeah, we'll put these in a PDF for you. Another term you hear a lot in LON is binding. This is the process of saying these two controllers, I want this point, this output on this controller to be tied to the input on this controller. So that what happens is when I bind those two, and it's a software thing that I say, okay, this controller, go get this point from this address and this point. So what that does is that allows you to have maybe a temperature from this controller shared with a temperature from this controller, and if your front end goes down, those 2 points are still talking and your process is still running. So you don't have to have the front end. So, you know, and always a good test, and we've all been burned by this, but you should be able to walk into a building and you have a Jace on the wall. Best case scenario, you take the Jace off the wall and everything runs like it should. Now it may all, say, well, I don't no longer have a schedule, so I default to on or off depending on what the building owner wants. But you should be able to go to a safe operating state without the front end. And you do this with LON by binding the points directly with each other. LON Maker, you may hear that. That's actually a network management tool from Echelon, so it's kind of their programming for their flat LAN system. So you won't use LAN Maker with a Niagara system, because Niagara doesn't use flat LAN. They because their system is not a true pure LAN system. XIF is a term used. You say I have a train chiller and it's got a LAN card in it. The XIF file that Train provides says these points, these are the points in the card that you have access to, and this is how to get to them. So Train would provide whoever's doing the system integration the XIF file so they know how to be able to bring those points in. And in some cases actually do some programming through the XIF.
So there's a little exception to the Jace rule on the LAN Maker or the flat LAN.
Yeah, so a Niagara system is not flat LAN.
It was not accepted.
Yeah, so it can't, because the definition, one of the definitions of flat LAN is it's a pure LAN system. And a Jace can do more than LAN. But also, since a Jace is more of a, it's kind of a front end, and everything comes below it, where flat LAN is everything's literally flat. There's no servers or clients. It's all one flat system. And so you can do a flat LAN system, and flat LAN systems work, but then you're tied to flat LAN from now on. So everything you do has to be LAN. So if you buy a new boiler and it just has Modbus in it, you have to buy additional hardware to convert that to LAN to get it into your system. And when you do LAN in a Niagara system, it's a lot easier, and a lot more people can do it because it is easier. A flat LAN system takes, it's a lot harder to engineer and program. A couple more terms. I think they call this a skip it. Basically, this is just saying that this is a point in the controller that's used for configuration, maybe like a set point or something. A function block is like a piece of equipment, like a node on your system. And that's it for LAN. Any questions on LAN? All right, so LAN really was the early adopter, like I said, because they took the hardware approach to things. It was a lot easier for controls manufacturers to say, I'm just going to buy your chip that you did all the development for, put it in my equipment, and now I meet an open protocol. But like I said, some of the disadvantages to LAN was actually more not only developed, it wasn't just developed for the building automation industry. It's developed for power line grids. It covers a lot more things, and that's why it's more complicated. And it's more of a European standard too. So there's a lot more involved with LAN because they tried to be a bigger umbrella. What Ashway did in 1996 was say, well, we just want building automation level stuff. We want to make it easier, which in turn makes it more affordable to be installed. So they developed BACnet. And BACnet stands for Building Automation and Control Network. And BACnet is a software-based platform. So on anybody's RS-45 transceiver chip, doesn't matter who makes it because a lot of people make them, you put the BACnet software on that and you have a BACnet device. So it's more of an open system as far as the hardware goes. But the problem with that is if this guy does his chip a little bit different than this guy, then you may have, yeah, they talk the same language, but maybe they have a different dialect, is a good way to say it. And sometimes what you'll see with BACnet is Ashray actually does a thing called Plugfest. And what they do is they get all these manufacturers in a room, they have one bus, and they try to plug everybody's stuff into that one bus and see who can break the bus. Because there may be some little difference in this controller that makes things start acting weird. And it's gotten a lot better than it was, and BACnet is really becoming king, so it is better than it was. And really, if you have if you have that problem with BACnet, it's a lot easier to break those buses up into different segments. If you have one piece of equipment that kind of doesn't follow all the rules of BACnet, because BACnet is an open protocol and people can kind of write their own proprietary stuff and put it over a BACnet bus, you can separate that stuff a lot easier with BACnet.
Why would you think of a scenario where that would be desired just now?
So an advantage of it being easier to put stuff on different buses and make them talk, when you convert BACnet, and we'll get into this with the different types of media that you do BACnet on, it's a lot easier to go from 2-wire BACnet to IP than it is in LONWORKS. So you have all these smaller buses that you can do, and then bring everything in over IP, where it's a lot faster. So instead of having one long bus that's a slower bus, you have smaller, slower buses that get up to a faster interstate. So think if the whole state was just 2-lane highways, it's a lot slower to get from point A to point B, where they can jump on an interstate and get there a lot faster. So the two most common types of BACnet you run into in buildings is MSTP, which stands for Master-Slave Token Passing, and BACnet IP. So 95% of all the controllers in the buildings are going to be MSTP. And that's because it has the advantage of being a 2-wire bus. If we did everything IP, I don't know if you know this, but a Ethernet cable can't be longer than 300 feet. And you can't daisy chain it. Everything home runs on Ethernet. You go from the computer to a switch. So the advantage of buses is I've got this building that I need to get all above the ceiling. I just run a 2-wire bus, and it's a lot cheaper on the install. A lot more cost effective to install that bus. So the way MSTP works is it's a master-slave network, which means there's one device that's controlling all of the communications to all the other devices. The TP part, the token passing, that master actually changes. So it's in effect becomes a peer-to-peer network. So there's a master on the network at all times, but that's not the same master. That master keeps changing. That's getting a little more advanced, but that's just kind of an explanation of what the MSTP is talking about. So you still have peer-to-peer communications even though you're on a 485 network. So what BACnet did with this is they took traditional 485, which was Modbus or COM4 or N2, which has one master that has to handle all the communication. So if this VAV needs to send data to this VAV, it's got to go through the master. Well, with this technology, the master changes, so when this VAV needs data from here, when it's his turn to be the master, he just goes straight and asks for it. So it's a lot more efficient way, and that's why you have a lot more features in BACnet because you get away with it. All right, so MSTP can be a 2- or 3-wire bus. 3-wire bus is better. It's a lot more robust, and it's a lot less. It's a lot easier to install as far as getting away with problems. The problem is it's more expensive. It's another wire, and it's more expensive to make a 3-wire bus controller. So most manufacturers, when you have a BACnet thermostat, it's just got 2 places to put wires. It doesn't have the reference. And that's just because money drives the industry and budgets. Not all manufacturers can afford to say, I'm just going to be 3-wire, which is better. Their controls will never be installed. There are some like the Johnson Controls PCG line, which is the open line for like Niagara contractors to get, and even their branch stuff, their new FC BACnet stuff is 3-wire. It's basically the same controller. I can configure an MSTP trunk to be different baud rates. Remember, LON was just one baud rate. It was 78,000 baud, which is pretty fast. The advantage of being a configurable baud rate is if I have a BACnet bus, it starts having some communication issues. Maybe traffic's moving too fast across it, and they're not getting off at the right exit. To continue the analogy, I can slow that bus down. I can have a smaller bus slowed down and fix a lot of communication protocols without having to go around the whole building, my whole 4,000 foot bus, trying to figure out where the problem is. You can run distances up to 4,000 feet. It's addressed, it has two addresses. A BACnet device has got two addresses, and we'll go into that in the next slide. And like I said, 485 can have its own set of challenges. I'm sure all of y'all have run into a bus where things start acting weird because of the 485 network. It's a lot more finicky than a LON network. So a BACnet device has got two addresses to it. It has a MAC address and it has a device instance. And going back to the LON talk, the MAC address is more like the Neuron ID. It's the address for that bus. It's 0 through 127. So, if I have, a BACnet bus, say I've got a router, and then I've got a bunch of VAV controllers going off of it. The MAC addresses will start at 1, 2, 3, 4, 5. And that just handles the physical communication on that bus. The device instance is more of the software level, where it's a unique number across the whole system. No matter how many buses you have a unique device instance within that system. So MAC address is only used on MSTP. Device instance is used both on MSTP and BACnet. So if you have a BACnet only controller, it only has a device instance because it's not on a physical bus, so it doesn't need the MAC address. So you'll hear those two terms, MAC address and device instance. They are two separate numbers. BACnet IP. So this is kind of why BACnet's taken over, because BACnet IP is a lot easier and a lot more cost effective than doing LON IP. It's transmitted over a network, and that could be the building network or that could be the internet. Say you had a small site with a couple of thermostats that, if I have just a thermostat and I lose BACnet communication, my piece of equipment is still going to run. It's just a thermostat. Maybe it doesn't get the schedule anymore and I can't see what the temperature is, but it defaulted on and it still runs. So if you have an outpost, a small building off by itself that has 5 thermostats in it, and you don't need a front end there, you don't have to put a Jace in that building, you can put a BACnet IP router in that building and route those 5 thermostats information to another building that has a Jace in it. So you can be a lot more cost effective that way. Obviously you don't want to do that with mission critical type stuff where you're passing data that's running a chiller plant. But if you've got something, a system where if I lose communication, everything still works, that's a pretty good solution. And that's wrong. It's address with IP addresses and device instances, not MAC addresses. I need to fix that. And BACnet IP can use the building's existing network. A lot of times it's hard to get on a building's network and you have to run your own network. But it does run just on a computer network. And BACnet is a lot easier to route and get from an MSTP up to an IP level protocol. It's a lot easier to do it with BACnet. BACnet routing, you use routers like these, and that converts it from that 2-wire bus to Ethernet to do the scenario where, like, if you have a small outbuilding with 5 thermostats or something like that in it. Some terms you're hearing BACnet. Object. In BACnet, an object is basically a general reference to a sensor actuator device. So my object on a BACnet controller is the space temperature. And each object has a property. So that space temperature has an object property, several object properties. One of them, most common, the one we care about, is present value. What is the present value of that temperature? But then also has some that are, bad sensor, maybe something's out of, unoperational, min and max ranges that are valid for that sensor. So if you have a space temperature sensor and it's reading 0 degrees and your minimum is 30 degrees for that particular sensor, it'll generate an alarm saying the sensor's bad. COV. COV is change of value. So with COV, what I can say is I need to know when this sensor, I need to know the value of this sensor. But I only need to know it if it changes 3 degrees or more. So if I have a 3-degree change, I need to get an update. But if it changes 1 degree, I don't need to get an update. So I don't need to put traffic along my bus polling this piece of equipment or this sensor every second to get an update when it only changes at 1/10 of a degree. So you use COV and you say if this value changes more than whatever you set it at, I go tell the controller you need to come get my new value. We kind of talked about the MAC address already. This is the 0 to 127. This is the dip switches you set on the controller. And some BACnet controllers don't have dip switches, like some of the thermostats. You actually set the address in the thermostat itself. It doesn't actually have it. It does the dip switch via software. Max masters, basically, so on this token passing network, you start at address 1 and you say, I'm the master. Do I need to get any information? And if you say no, I say, okay, I pass this to address 2. Well, if I leave my max masters at 127 and I've only got 20 devices on my bus, when I get to 20, it's going to ask, is there a device 21? Is there a device 22? So it's going to spend time seeing if any of those other devices above 20 were added. So I can say this is the maximum number of devices on this bus, and it goes back to 1 instead of polling all these dead.
Is that, when you say devices, that's like controllers, right?
Yeah, controllers on that particular bus. BACnet IP addressing, use a standard Ethernet IP address. So the same kind of address that your computer uses when you get on the Wi-Fi or you plug into the wall. And device instance, what we talked about, that's the software address of the device. So that's a system-wide address. There's only going to be one device instance of 1001 on the whole system. I may have 4 different trunks, and those trunks each have a controller on there that's dip switch set to 1, but since they're on different physical 2-wire buses, that's okay. But they all have to have different device instances. This is more advanced. I just wanted to put this on the slide so when you do get the slide, you've got a reference to them. This is a pretty good explanation of client-server versus master-slave, that terminology. Client-server is more terminology used when you're talking about BACnet IP. Master-slave is when you're talking about MSTP, the 2-wire bus. And a BBMD is a device that can be embedded in a router or can be a separate device, and that handles if you go across the internet and you have a router on one network and a router on another network, that's how those 2 routers talk. All right, so I put Modbus on here because you're all going to run into it. Modbus was first developed by Modicon in 1979. It's been around forever. It was designed for a way for their PLCs to talk to each other. It's a very simple protocol. Doesn't have a whole lot of features. I can't go to a Modbus network and hit discover and it polls to see how many devices I have out there. I can do that with a BACnet or a LON. Modbus is very simple. You've got to manually do everything, but it's really robust. Since it's so simple, there's nothing really to break on it. Well, why do we care about Modbus if it's an industrial protocol? Since it's been around forever, it's open protocol. It's very easy for a manufacturer to put Modbus in a device. So a lot of them come with Modbus right out of the gate. They don't have to have any kind of adapters or separate cards. A lot of devices come Modbus. And you see it a lot in sub-meters, switch gears, gas detection sensors. So you do pull in, even though it's an industrial protocol, you do use it a lot in the building automation space. Three common formats of Modbus just to be familiar with. Modbus RTU is the most common. That's the 2-wire bus. That's usually what all your sensors and meters and stuff are. There's a Modbus ASCII that's not as common. It's still a bus system. It's just a different dialect, for lack of a better term. And then Modbus TCP is Modbus over Ethernet. So you can route over the internet. So a new protocol, I'm sorry, any questions on Modbus or BACnet?
You can't really tie up. You already said that for the Modbus to anything else, right? PLCs, they can communicate with each other on their system.
If it's Modbus, you can get a Modbus driver for a Jace, and if it's talking Modbus, you can pull it in. Still, it's still a standard protocol. So I can have one manufacturer's Modbus device talking to another manufacturer's Modbus device.
Yeah, but you won't necessarily get it stopped with BACnet.
Yeah, it can't talk to BACnet without some kind of gateway or a Jace or something like that. They can't be on the same bus. Even though they're both 2-lane highways, they're both RS-485, the street signs are in different languages, and so everything starts crashing together.
So you wouldn't have your machines out on the industrial floor. They only communicate to the BAS or something like that.
Yeah, you can't put it right on that network. You can they have gateways, so if you have, and this is common, you know, I've got a BACnet bus in my system. My front end, my Jace is on this floor, and I'm talking about 3 floors up. For me to run another wire from that device all the way down is not feasible. So you can actually, they have gateways or converters that I could say, okay, well, I've got this one Modbus device here. I've got a new burner controller on my boiler that I want to be able to pull in some more data off of. I can put a gateway in, which converts the Modbus to BACnet. It's got to buy another piece of hardware, but sometimes that's more cost effective than running a new bus throughout the building. We don't really have a cost-effective way to do that with Rob's scenario with N2 and BACnet, but with some common protocols like Modbus, Modbus to BACnet or BACnet to Modbus, there's some solutions out there for that. So SNMP is more of an IT protocol. So the building's IT people already know what this is. If you Google SNMP, you're not going to pull up some kind of HVAC site. You'll pull up Microsoft.com or IBM. They've got their own tutorials on SNMP. It stands for Simple Network Management Protocol. And it's used to talk between devices on a network. So printers, computers, servers, UPSs on a network so they can talk to each other. Why do we care? Because everything now is getting put on the internet. You know, all of our buildings, we can pull them up from the internet. So everything's getting on the IT people's network. So that's why we're seeing more of it, because IT people are saying, I want the data in this format to put on my network, or while you're on this network, I want you to pull in this stuff, or I need alarms from your system to go to my server so I know to start shutting servers down if it gets hot, so I don't fry anything. It's very popular in data center stuff, but we're seeing it more and more in just large building stuff. They have their own small data center or maybe a UPS that they want to monitor. And what's nice about it is it's a protocol that the IT department already knows and understands. So if you're a contractor and you're having trouble getting on a network, or contractors and IT people don't always see eye to eye, and the IT guy doesn't think you know what you're doing and doesn't want you anywhere near his stuff because he's security conscious. But he knows what SNMP is, so that's why it's become more popular, because I can go, well, I can give you this information this way, and he goes, well, I understand that, that's fine, send it on. Here's some terms. We already went over SNMP. You may hear MIB if you're dealing with SNMP. That's the Management Information Base. Basically, kind of like an XIF in LAN. It's basically saying this is the data available from this device. And OID is how SNMP devices are addressed. And it's a really long addressing scheme. Because it is on the internet and there's so many devices, they have these very long addresses. Get set are some terms you're here. That's just read or write on their network. A trap, basically that's saying, use the trap with an alarm. You send that out across the network saying, hey, I've got an alarm, and they call that a trap for whatever reason. And then there's different versions of SNMP. So that's one thing that you may have some trouble with, is this IT department only uses version 2 stuff and you only have version 1 stuff, vice versa. So that's pretty much it for the quote-unquote open protocols. Those are the 4 most common we see today. Any questions on those? So a lot of you already have buildings that have proprietary systems in there. A lot of train buildings in Atlanta. Like Rob said, we can still take some train devices and hook those right up to a Jace, so you don't have to replace devices. So with train, we can, a lot of COM4 devices out there. It's got a large installed base, and you can integrate COM4 devices with Niagara. So if you have a COM4 building, you can bring that into Niagara. If you have some older COM3, you'll hear COM4, COM3, COM5 with train. COM5 is LAN. COM4 is their newest proprietary network, and it talks RS-45. And then an older one is COM3. And there was 2 different flavors of COM3, non-isolated and isolated. The non-isolated one was a lot of those very trained VAV controllers that were out there. We can integrate those. There is ways to get those into a Jace. The COM3 isolated stuff, you can't integrate that. You can't bring that data right into a Jace. You'd have to leave the building's BCU in place and convert that data to BACnet using the BCU to get it to another front end.
COM3, you gotta have some kind of gateway.
If you have COM3 isolated, typically what our contractors do, if you've got a contractor that's train savvy, they'll leave the existing train BCU, the building controller the train had there, in place, and then basically convert the COM3 data to BACnet IP and use the train BCU as a gateway. I don't know how to personally do that, but we have contractors that can do that. Another popular one is Johnson Controls N2. We kind of already talked about that. Very large install base, but it can be integrated into Niagara, and it doesn't have to just be a Johnson Controls Jace. You can have a Honeywell Jace, a LinkSpring Jace, an EasyIO Jace, and bring an N2 network right into it. There are drivers for Siemens Apogee systems, so you can bring a P1 protocol system right into a Niagara system with that, so that you don't have to replace your existing controllers. And these are just some of the common ones. There's a whole list. There's probably 30 different drivers we can get. I just hit the 4 most common ones you'll run into here. And then Honeywell. Not as big an install base down here in the south of Honeywell. There is some of it here. The C-Bus, their proprietary network is called C-Bus. It can be integrated into Niagara. Certain controllers can. So there are some limitations and restrictions on what can be brought into a Niagara system with an existing C-Bus system.
And all this is going to be covered on email.
Yeah, I'll take this slide show and we can email it out. So those are the 4 I had. Any questions on those?
Siemens, Honeywell,
Johnson. But like I said, there's 30, 40 other drivers. You can get drivers for PLCs. You can get. That's one nice thing about the framework that Tritium developed with Niagara is other companies can write drivers for other stuff. So Johnson Controls, when they came out with their Jace, they actually have their own N2 driver that they wrote. Now, some other companies wrote N2 drivers to be able to put them on other Jaces because Johnson said, "Where if you want our N2 driver, you have to buy our Jace." There's third-party drivers out there, so you can pull into other Jaces.
Yeah, but you get their Jace in order to make their system available to other.
Well, no, what Johnson said is, okay, one advantage we're going to say, if you sign up and you become a Johnson Controls contractor, you know, I want to be an automation contractor, and Johnson says, well, if you sign up with us, we wrote and developed our own N2 drivers that you get free on all of our Jaces. You buy our Jace, you get this driver, it's included. Well, not to leave out the other contractors, another company went in and said, well, we're going to write our own N2 driver. You have to buy it. But you can still say, I have a Honeywell Jace, I can bring your N2 devices in.
It's almost seems like they're trying to walk backwards a little step. Because the whole idea is to try and make it more generic for everybody.
Yeah, I guess back to the levels of open conversation Rob had.
Yeah.
You know, I can have a BACnet controller, but if this is the only company in my area that can have the software to program that BACnet controller, yeah, it could talk to anybody's BACnet device. But if I need to make a change to that controller, and I got to call I can only call one person to make that change, how open is it? You know, it's great when you come in and they have a BACnet controller, and I can say, yeah, I can pull that data in. Anything exposed on the BACnet, any points that I can discover off the BACnet, we can pull in and do a graphic for. But if the customer comes back and says, you know, 6 months down the road, I need to make this slight change in the sequence of operation for this program, you'd have to replace the controller or call in the company, you know, the branch company is the only one that can program that controller. So there's different, you know, levels. And it even gets down to there's different levels of open on BACnet or LON. Because those are open protocols, manufacturers can say, you know, we talked about those SNVs, those standard network variable types on LON. There's actually custom ones that a contractor can write to. But the problem with that is if I have a custom type of point on my BACnet or LON device, the only thing that can see that custom type of point is my other controllers that are programmed with that same custom type of point. So they all play games to try to say, yeah, we're open, but how open are you? Type stuff. But the key is to always be moving more towards the open, and that's, you know, what Rob was talking about. Always, you know, say I want fully open JACEs. You know, I want stuff that anybody can work on. That type of stuff. Maybe not so much anybody, but maybe more than one option. You know, if you have a Johnson Controls controller that goes through their tritium side, through the contractors, well, maybe a Honeywell contractor doesn't have the tool set to reprogram that, but you've got 10 Johnson contractors within distance of you that can come in and work on the system.